The factory method pattern defines an interface for creating an object, but lets the classes decide which class to instantiate. The hell does that mean? What is going on, everyone? My name is Adam with Pragmatic Ways, and today we're going to be going over the factory method pattern. Now, that definition I was just reading there, it came from this book called Head First Design Patterns. And this is by far, hands down, the best book to learn about your design patterns. So if you're actually looking for a good book to help supplement in addition to these YouTube videos, then I'd highly recommend this one. I have an affiliate link for this book in the description below. So you click on that link, you go over to Amazon. It costs you the same whether you use my link or search up on Amazon, but if you use my link, I get a couple extra pennies, you help support this channel, so on and so forth, blah, blah, blah. Anyways, pick up this book though to learn your design patterns. It is by far, like I said, the best book to actually learn your design patterns. But without any further ado, let's actually get into it and actually learn about the factory design pattern. Alright, so a lot of times these definitions to these design patterns can kind of get a little bit confusing. So let's just try and break it down. You know, we'll read the definition and then we'll start breaking it down of what it actually means. So in this book, they define the factory method pattern defines an interface for creating an object. Alright, so we have an interface to create an object, but let subclasses decide which class to instantiate. So why would we want that? We'll explain that in a little bit. Here's another really important part though. The factory method lets a class defer instantiation to subclasses. Okay, so like I said, a little bit bloated, a little bit confusing. Let's really break that down here. Okay, so I like using the example of a beer. All right, if you don't like beer or you don't drink beer, you know, you can substitute it with coffee or pizza. They actually use pizza in this book. All right, but what am I getting at here? Okay, so let's say I want a beer. Now I could create all the logic. I could have all the logic for creating a beer inside my head, right? I could know how to do that all myself, but I don't really care to do that. There's so many different types of beer, right? There's IPA beers, there's stout, there's porter beers, there's lagers, a light beer, dark beer, so on and so forth. There's so many different types of beer that it wouldn't make sense for me to know how to create all these different types of beer. So what I'm going to do is I'm going to delegate that sort of creation logic to a certain class, and they're going to handle the instantiation of all the different subclasses of beer. So all these subclasses have a common interface. That common interface is beer. Me as the client, I don't care how the beer is created. I don't care about all these different subclasses and how they're created. All I care about is that beer. And I'm going to handle the delegation. I'm going to delegate the instantiation of this beer to a different class. And that class will say, okay, he wants a beer. I'm going to create one of these subclasses, or I'm going to create this subclass instead, or I'm going to create this subclass instead. And then that class hands me the beer. If you're still confused, let's jump over into some code and I'll try and explain what I mean a little bit better. Alright, so we're going to take a look at the factory method pattern in action here. But before we do that, just to let you all know, I am going to be using the Java programming language, and I'm also going to be doing it in an online compiler. And the reason I'm doing it in an online compiler is because for all you non-Java programmers out there who are watching this video, I don't want you to feel like this is a Java-only thing. You know, I'm not going to be doing it in my own IDE where I have IntelliJ installed and everything else. You know, we're really just trying to learn the concept of this pattern and not really focus so much on the implementation inside Java, but really the overall concept so you can apply the same principles of the factory method pattern to your programming language. So I'm just using an online compiler, make it real simple for you all. All right, and with that as well, if you like blogs, I also wrote a blog article on this exact topic over my blog at Pragmatic Ways, factory design pattern. So, you know, I got some pictures in there, ULM diagrams, the code snippets, so you can follow along, so on and so forth. So head on over there if you want to supplement with this video here. And without any further ado, let's actually move on here. So what's going on here? First, this is not the factory method pattern that I'm showing you. This is sort of the bad way of doing it. And the reason I'm showing you this is that way you can know when you're going through a similar sort of scenario like this, you can take a break and pause and just think like, oh wait, I've seen this thing before. This could really benefit from using the factory method pattern right now. All right, so what is this class doing, or what is this program doing right here? Well, first, the overall idea of the program is that I'm trying to create a beer. And the way I decide what beer I want is going to be based on the day. So first thing I need to do is get the day of the week, and then I say if the day of the week is Friday, I want to create an IPA beer. Otherwise, if it's not Friday, any other day of the week, I just want a stout beer. Okay, that's sort of the creation logic to create a certain type of beer. And what these different classes are is very simple classes. They just have a couple private methods for the certain steps of creating a beer, and then a public method for brew, which actually creates the beer. It actually brews the beer. And with this one, it's going to be malting with rye grains, 170 degrees, steeping at 170 degrees, boils for 16 minutes, sits for 14 days, and then finally, your IPA beer has been bottled. And then the stout beer class looks very similar, has all the same steps, has the same public brew method to perform the different steps, but the steps themselves are a little bit different. So this one's malted with oat grains, and then this one's boiled at 160 degrees, and boils for 75 minutes, 16 days, and then finally your stout beer has been bottled. And then for any of you beer enthusiasts, I actually don't know how to brew beer. I did some very little research on how to actually brew beer for the very purpose of this video. So if these steps are wrong, which they most likely are, I'm sorry. Again, this is just for the concept, not really the implementation of brewing a beer. Anyways, moving on. Another thing. I do not really advocate this convention of writing methods all in one line in any way, shape, or form. Again, this is for the sole purpose of condensing this code to make it easier to show on the screen during recording this. But okay, moving on. So these two classes, first thing we might notice is that these two classes are very similar, right? So well, let's keep that in mind. We're going to go ahead and run this class here, and since today is Friday on the day of recording this video, we should expect that we will get the output for an IPA beer. So I'm going to go ahead and run that and see what our output shows, and of course, your IPA beer has been bottled because today is Friday, and we wanted to create an IPA beer. If I were to change this to Monday instead, well, today's not Monday, so we should expect that a stout beer is instead created. And we will see our output comes out with all the steps for creating a stout beer, and then our stout beer has been bottled. Awesome. So this is the bad way of sort of handling this type of program. And why is this bad? Well, for starters, I have all this different logic in here in order to create a beer when realistically, I just want a beer. I don't need to know what type of day it is, I don't need to know all the creation logic. I'm just trying to get a beer. I don't care what beer it is. There's so many different types of beer. The example I use in the blog is that there's so many different types of beer out there. There's IPA beers, there's stout beers, porter beers, dark lagers, light lagers, so on and so forth, that, creating all these different beers, that's way above my head. That's too much for me to handle, and I don't really care about that. I just need a beer. So I'm going to delegate all of this logic of creating a beer to an assistant, all right? And I want my assistant to sort of pick and choose what beer I should drink. So I don't care what sort of logic they come up with. I just want a beer. I want a common interface to drink a beer. What type of beer it is, whether it's a stout beer, a IPA beer, a dark lager, light lager, so on and so forth. I don't really care about any of that. I just want a beer. So that's sort of the problem with this. One of the problems is that I have all this logic in here when realistically I just want to interface with the beer. Another thing is just poor programming in general, and we can see that these two classes are almost the exact same, but they're not following a sort of interface, or they're not subclassed from a certain super type or anything like that. So let's start there. Let's sort of make these extend a certain subclass or a certain super type, because that's gonna just make our code cleaner. If we need to change anything of the steps here, then our program then our code is really gonna help us to just keep everything clean and know that we need to change it all. So first thing I'm gonna do is just create that super type, and this is gonna be an abstract class. I'm just gonna go ahead and say, all right, this is going to be the public abstract class of type beer. And this is gonna, again, be very, very similar to all of our other classes here, but it's gonna be the super class, and all the other classes will need to extend these. So instead of making these private, these are going to be protected, and they're also going to be abstract, because I want the other classes to be able to implement these. So I'm gonna go ahead and Control-C that, and Control-V those. And then our public method can stay the same here. So that's it for this class here. And now I need all these other beers here to extend our new beer class. We want all these other subclasses to extend that class here. So this is going to be protected. Then we need to change all these from private to protected. So still the public can't access them, but we know that they can be extended through our beer subclass. We know that they're supposed to be from the beer superclass, sorry, abstract class. And then same thing with this one. It's going to extend our beer class, beer. And there. So now, just right off the bat, just off of doing that, we should expect that our class, our program hasn't really changed all that much. We should still be able to run the program just as the same way we did before. But one of the benefits we have now is, notice here, our beers, I'm creating a specific IPA beer. I'm creating a specific stout beer. And now the scope of this beer has to be contained within this. So again, going back to problems of why this is a bad design, is that any sort of other logic I need to do, it now needs to be contained within this if-else statement here. So since we created that abstract class, well, at least now we can pull the scope out a little bit further, and we can create just a beer. I'm going to say beer, my beer, equals null right off the bat. And now I don't need to do this. Oh, come on, I can't type. Now I can just say my beer equals a new IPA beer, or my beer equals a new stout beer, and I can take this method out of here, Control X that, and just completely delete that. And now I can brew the beer outside of the creation logic here. And now it's not, again, because this isn't contained within this scope anymore, and now this beer, it could be an IPA beer, or it can be a stout beer, that's going to be created within this if-else statement. And let's just go ahead and run that and make sure everything still comes out handy-dandy here. And it does. And again, we should have a stout beer here. And just to sort of verify, let's bring this back to Friday, and we'll run it again, and it should create the IPA beer instead. And sure enough, we still have our IPA beer. Awesome. But now this isn't really using the factoring method pattern now, is it? This is really just a basic example of using polymorphism inside some object-oriented programming language. I mean, all we really have is some abstract class here, our supertype class of a beer, and then we have two different subclasses, both of which extend our supertype. And then, we create our supertype here, and then inside of our if-else statement, we're actually instantiating what type of subclass we want, and then down here, we're polymorphically using the broom method. And there's nothing new here. We've seen polymorphism, we know about inheritance and abstract classes, so why is this design still bad? Why is this a bad design? Well, again, we have so much creation logic in here within our main class. We have to know the day of the week when we don't really care about that. We just want a beer. And then we also have all this if-else statement in here. And really one of the bad things is this is such a small example that imagine if we have this same creation logic elsewhere throughout our application, which we most likely will. We're going to have it in probably a few different places. And now if we ever need to change something, let's say we get a new beer type, let's say we want to create a porter type, and we want this type of beer to be created on a Thursday. Well, we have to go inside we have to find all these different if-else statements and add our new type in here. And, who knows how many different creation logic places we will have this sort of if-else statement. And then same thing, anytime we need a new beer or anytime we need to change up this sort of creation logic here, we need to go and find all these different examples of where this creation logic is to sort of update that. So how can we fix that and sort of consolidate or isolate the creation of our different beer type? Well, we're going to use a factory pattern. So how do we actually do this here? If we remember from our definition, it was that we're going to delegate this to a certain class, and that class is going to be our factory class. So let's go ahead and do that right now. We're going to create a beerfactory.java, okay? And this is just going to be, again, another class. We're going to do a public class called beerfactory. And this class is going to have a public method called, getBeer, but the return type is going to be of type beer. Let me put that in, because So we need a return type in there. All right. So what this class is going to do is essentially it's going to create our beer with the creation logic for us. So it's actually going to be this exact logic here. So I'm just going to go ahead and copy that and then paste that. And since I'm using that calendar object again, I need to import that inside my beer factory. So import that bad boy right up there. And I don't even need that anymore. All right. All I need to do is get the day of the week and then use my creation logic. And then down here, I can just return, and actually, before I even do that, really, I guess really what I could just do is just return new IPA beer or return new stout beer. And that's it. That is the beer factory right there. That's all we need to do. But now, of course, obviously, we need to actually utilize that in here. So we don't need this anymore. And we don't need this anymore because all this is handled for us in our beer factory. But what we do need to do is we need to create an instance of our beer factory. I'm just going to call it beer factory. That's going to equal a new beer factory. Okay. And then I'm going to create a beer equals my beer equals null. But instead what I really could do is I could say my beer equals beer factory dot get beer. And I can go ahead and delete all this actual creation logic because I don't care about any of that. And there, I say my beer equals beer factory dot get beer. That's going to go in here and do the exact same creation logic that we said before. And that's going to return an IPA beer or a stout beer based on the day of the week. And then it's kicking that beer back out here. And then that's what that beer is. It's either an IPA beer or a stout beer now. But again, inside this client here, inside this main class client, I don't really care about that. All I care is that my beer gets brewed. So if I go ahead and run this, and I should see everything still works all handy dandy. Nothing has changed. Except for the fact that this main class is now a lot cleaner. Look at that. I condensed it down from like, what was it, like 15 or 20 lines of code down to just realistically three lines of code here. And what's really great about that is imagine that, again, this sort of creation logic was in like 5 or 10 different places of our code. We now only need to update it once. We only need to update it in here. So if we create a new beer type, like let's say this is now a porter beer.java, and it's going to look almost the exact same as all these other ones, except it is now a porter. And maybe it's still made with oat grains, but maybe this needs to be at 150, and then this one only needs 70 minutes, and maybe it's for 17 days. I, again, have no idea how to actually brew a porter beer, but let's just use that for example. And now in our beer factory, let's say our assistant decides to change it up for us, and on Fridays, we actually get a porter beer. And then says, nope, not that. Else if day equals calendar dot, let's say Saturday. On Saturdays, we want the IPA beer. And then, else, return the stout beer. So now we would expect that we get our brand new porter beer right here. And let me just make sure, yeah, I did. Okay, cool. So now we can run this again, and we would expect that we're going to be brewed a beautiful porter beer. How simple is that? We don't have to go inside the if-else statement in our main class and contaminate our main class. We didn't even touch our main class. Or any of the other 10 places that this sort of creation logic might have been. We only need to do it now inside of our beer factory. And that's really the power of the factory method patterns. It's just a real clean implementation of sort of instantiating a class of a couple different subclasses that all have the same common interface, right? I can't move them around, I guess. I was going to try and organize them. But anyways, we have these 3 different subclasses here that all extend from our beer supertype. And our beer supertype is our main interface that we really only care about in our main class. But our beer factory is going to instantiate one of these several different sort of subtypes. And that follows almost exactly of what our initial definition states back from our book of Head First Design Patterns. All right, so now that we've seen what it actually looks like in action here, let's go back to the book to actually read the definition to see if we can understand it a little bit better. All right, so the book defines the factory method pattern as an interface for creating an object. So our beer, our abstract class of a beer, that is our object. But let subclasses decide which class to instantiate. Factoring method lets a class defer instantiation to subclasses. So that's kind of what we did, right? It's a little bit different, and I'll explain that in a minute, but that's kind of what we did, though. We're letting a class decide what different types of subclasses we want to create. We have a common interface of our beer, our abstract class of a beer, and then from that common interface, we have several different subclasses. We have an IPA beer, we have our stout beer, and we have our porter beer. And then our beer factory, we're delegating the creation logic of a beer to our beer factory. And our beer factory is going to decide, all right, you're going to get an IPA beer, or you're going to get a stout beer or a porter beer. And then it's going to instantiate that polymorphically as an actual beer, and then send our beer back out to the client for us. So that's kind of what we did, but again, what this book sort of goes more in detail of, and it explains that what we just implemented here is what's referred to as the simple abstract factory, or the simple factory method. And then it gets a little bit more in detail of sort of more complex versions of the factory method pattern. So that was just a very basic sort of idea and explanation of the factory method pattern, but we're going to go deeper into it, and that's going to be in subsequent videos though, so make sure you check the description below for when I do post those videos. Also check that description for this book right here, the link to this book. You can go check out that link, head over to Amazon, and then pick up this book. If you haven't yet, head over to my blog, sign up for the newsletter. If you like this video, smash the like button. I think it's over here, or maybe over here, and then the subscribe button's over here. I don't know, do one of them, do both of them. Support this channel, and I'll see you all next time.